Hello class, this is Dr. Scott with your week 2 video tutorial. I hope though all of this is going to be a refresher for you. If it's not, and you need more than what I'm going to present here, call me. I'm happy to talk you through absolutely anything. And if it turns out that several of you need the same type of help, we can arrange a session where we're all together chatting about it. So fractions are part of our everyday lives. We use them when we cook, we use them when we measure things, and there are some times when we need to know things about fractions. So that's why it's important that we learn it. There are 3 different types of fractions. You see them listed here: proper fractions, improper fractions, and mixed numbers. A proper fraction is a fraction in which the numerator is less than the denominator. The numerator is the number on the top of the fraction, and the denominator is the number on the bottom of the fraction. Improper fractions are fractions in which the numerator is greater than or equal to the denominator. And keep in mind that if the numerator and the denominator are equal, that number is always 1. So 1 over 1 is 1, 2 over 2 is 1, 3 over 3 is 1, 2,027,000 over 2,027,000 is always 1. So that's a really important thing to remember when you're working with fractions. Mixed numbers are simply what we call a whole number with a fraction, such as 2 1/2, 6 3/4, 4 5/8, whatever. So now that we know these 3 things, proper fractions, improper fractions, you may remember them as top-heavy fractions, and then mixed numbers, which are pretty self-explanatory. So we are going to do some things with these, with fractions. The first thing we need to know how to do is how to convert improper fractions into whole or mixed numbers. And again, an improper fraction is one in which the numerator is greater than or equal to the denominator. So the first step, I guess I should step A, is to divide the numerator of the improper fraction by the denominator. So for instance, if we have 15 over 15, we know that's 1. Not only because I just told you, but if you take a calculator and divide 15 by 15, it will be 1. 15 goes into 15 one time. So if you have no remainder, the quotient is a whole number. For instance, if you have 30 over 15, 30 divided by 15 equals 2, because 15 goes into 30 2 times. So what if it's not neat and clean like that? And it's not a whole number. It ends up being a mixed number. That's okay. So let's say, let's just use the example in the books or in the lecture so that you can go back to it more easily if you need to. So let's say that we have 16 over 5. Well, the first step is, again, we divide the denominator. I guess I shouldn't make this separate. 16 over 5. First thing we do is we divide 16 into 5. 5 will go into 16 3 times, because 5 times 3 is 15. So we have the answer to this question is 15, remainder 1. I'm sorry, 3 remainder 1, not 15. I apologize. 5 divided by 16 is 3 remainder 1. Over 5. So then what we do with our remainder is we have 3 and 1/5. We just put our remainder over the denominator. So we now have a mixed number. 3 and 1/5 is the same as 16/5. And if this isn't clear, just let me know and I will find another way to explain it. So now moving on, converting mixed numbers to improper fractions. And I know you may be saying, what the heck? Why would I ever do this? But as we'll see a little bit later, this does become necessary sometimes. There are 3 steps to this process. The first step is to multiply the denominator of the fraction by the whole number. So let's use the example in the book. 6 and 1/8 equals 8 times 6 plus 1. All of this over 8. So what is 8 times 6? 8 times 6 is 48. And we add the 1 over 8, which is 49 over 8. Now I did all 3 steps there, and I apologize for that. So the first thing you do is you multiply the denominator of the fraction by the whole number. And that's what you got. So add the product from step 1 to the numerator of the old fraction. You place the total from step 2 over the denominator of the old fraction to get the improper fraction. And once again, once you have done this a few times, you'll be able to just keep going like I did without even thinking about it. But the first step is to multiply the denominator by the fraction. So again, 8 times 6. And then we add it to the numerator of the old fraction. So we've got 8 times 6 plus 1. And then we place the total from 8 times 6 plus 1 over 8 to get the improper fraction. So let's move on. Reducing fractions to the lowest term by inspection. So what do we mean by inspection. We mean looking at it. So, the step here is only one step, and it is to find the largest just whole number that will divide evenly into the numerator and the denominator. So for this example in your lecture, they use 24 over 30. So what number will go into 24 that will also go into 30? And remember, we're looking for the largest. So let's start with the smallest, actually. So we know that they'll go into 2. But both 12 and 15, which are 24 and 30 divided by 2 respectively, are also divisible by 3. So we know that 12 and 15 are divisible by 3, and 24 and 30 are divisible by 2. So, and we know that 12 or 2 times 3 equals 6. And I hope you can follow that. So again, I said that we want to find the largest whole number that will divide evenly into the numerator and the denominator. So we start small and we say, okay, these numbers, 24 and 30, are divisible by 2. And what we have when we divide these numbers by 2 are 12 and 15 respectively. We can't divide them by 2 again, but that's where we would start. We would try to divide them by 2. We can't do that. We have to divide them by 3. That's the next whole number. So 2 times 3 is 6. So we know, I shouldn't say equals because it's a separate step. So we now know that 24 divided by 6 over 30 divided by 6 will give us our answer. So what is 24 divided by 6? 24 divided by 6 is 4. What is 30 divided by 6? It's 5. So our answer is 4/5. I hope that makes sense. I know that when you know how to do this, sometimes I may skip over something that you need to know. And if that's the case, again, call me. My number is 724-315-5006. So next, we find the greatest common divisor. And there are 3 steps to this one. So the first step is divide the numerator into the denominator. And we're still working with 24 over 30. So 24 over 30 equals, and by 24 over 30, I'm talking about something I can't do in Microsoft Word, which is to put 24 over a horizontal line with 30 beneath it. So when I say 22 over 30 equals 24 divided by 30, it looks the same because it is the same. So how many times will 24 go into 30? It will go in one time with a remainder of 6. So now we divide the remainder in step 1 into the divisor of step 1. Okay, so our remainder was 6, and we're going to divide it by the divisor, which is what we divided into the denominator, which is our numerator, 6 over 24, or 6 divided by 24, which equals 4. Finally, we divide the remainder of step 2 into the divisor of step 2, and we continue until the remainder is 0. So again, 24 over 30 is 24 divided by 6 over 30 divided by 6 equals, so again, what is 24 divided by 6 is 4. And what is 30 divided by 6? That's still 5. So we still have 4/5 because, once again, there was no remainder in our step 2. Or I'm sorry, our remainder was 6. I apologize. So now, how do we raise fractions to higher terms when we know the denominator? There are 2 steps. And here's the problem that we're given in the lecture. 4 over 7 is equal to what over 28? So that'll put it in a little bit of perspective. First step, divide the new denominator by the old denominator to get the common number that raises the fraction to 2 higher terms. So what do we mean by this? Well, we know that, well, we don't know anything. Let's just do what it says. We're going to divide the denominator, which is 7, by the old denominator, which is 28. And that equals 4. The next step is we multiply common number from step 1 by the old numerator and place it as the new numerator over the new denominator. So 4, because remember we have 4/7, 4 over 7 equals what? Over 28. So we came out, we divided 7 by 28, and we know that answer is 4. So we take our original numerator, 4 times the number that we got when we divided, 4 over 28. So 16 over 28 is our answer. Now, is this the best form of this? No, but we're not going to reduce it at this point because that's what, I just don't want to confuse you. We'll get there. Okay, adding like fractions. And those, by like fractions, I mean fractions that have the same denominators as each other. There are 2 steps. Add the numerators and place the total over the denominator. And the problem we're given is 1 over 7 plus 4 over 7 plus 5 over 7. And that equals 1 plus 4 plus 5 over 7. Oh, I'm sorry, but we can still do this. The problem we were given in the lecture is 1 over 7 plus 4 over 7 equals 5 over 7. And that, of course, would be 5/7. But this is a different problem, and it has a very similar solution, though. So 4 plus 1 plus 5 is 10 over 7, which again is an improper fraction. And if we want to reduce that to a mixed number, we can go up to one of the prior steps. So the second, this actually addresses it. Second step, if the total of the numerators is the same as the original denominator, convert the answer to a whole number. If the total is larger than the original. Convert the answer to a mixed number, which we will do now. So remember, to convert, we basically just divide the denominator into the numerator. And we know that 7 will go into 10 one time with a remainder of 3. So 1, remainder 3. This isn't even an equal, I'm sorry. So then the answer is 1 3/7. So now finding the least common denominator. When you were in grade school and high school, you probably heard this referred to as the lowest common denominator. And you'll see it in your book a lot referred to as LCD. So whenever you see LCD, that refers to the least common denominator. Okay. The smallest non-zero whole number into which all denominators will divide evenly is the least common denominator. So again, the smallest non-zero whole number into which all denominators will divide and the problem that we're given here in this part of the lecture is 3 over 7 plus 5 over 21. So we know that the smallest non-zero whole number into which all denominators will divide evenly is neither 7 nor 21. I'm sorry, it's not 7 because 21 does not go into 7. So there's a couple of ways to do this. And what the book suggests that we do is that we multiply the larger denominator, which is 21, by 2, which gives us 42. However, we know just by knowing our multiplication tables that 7 times 3 is 21. And that is our least common denominator is 21. So you can, if you want to, 21 times 2 equals 42. And if you do that, then you know that you still have to come back and say that 7 divided by 21 equals 3, which means that 21 is the lowest common denominator. So then 3 over 7 becomes 3 times 3 over 7 times 3 plus 5 over 21, which equals 9, not 8, 9 over 21 plus 5 over 21, which is the same as 9 plus 5 over 21, which ultimately ends up being 14 over 21. And those of you who just really want to reduce that down, feel free, but that's not part of this exercise. So how do we add unlike fractions? There are 4 steps. And here are the fractions that we're given. First step, find the LCD, the lowest common denominator, or the least common denominator. And in this case, it is 72. So the next step is to change each fraction to a like fraction with the LCD. So then we add the numerators and place the total over the LCD, which gives us 24 over 72 is what 1/3 becomes. 9 over 72 is what 1/8 becomes. 8 over 72 is what 1/9 becomes. And then finally, 6 over 72 is what, not 27, 72, is what 1/12 becomes. Then again, 24 plus 9 plus 8 plus 6 over 72. So 24 plus 9 is 33, plus 8 is 41, plus 6 is 47 over 72. Next, we add mixed numbers. And there are 3 steps. Add the fractions. Add the whole numbers. Combine steps 1 and 2. So what do we mean? So 4 and 7/20 plus 6 and 3/5 plus 7 1/4. So our first step is to add the fractions. So 7 over 20 plus 3 over 5 plus 1/4. Now we know that 4 times 5 is 20, so that's the lowest common denominator. So 7/20 plus 3 times 4 over 20 plus 1 times 5 over 20. And again, in case this wasn't abundantly clear, 7 over 20 stays 7 over 20. 5 times 4 equals 20. But that means that we have to multiply our numerator by 4. And 4 times 5 equals 20. So that means we need to multiply this numerator by 5. So 7 3 times 4 is 12, plus 1 times 5 is 5, over 20 equals, see, 7 plus 12 is 19, plus 5 is 24, over 20. Which is also, again, how many times does 20 go into 24? 1, remainder 4. So that means that the ultimate answer here is 1 4/20. Now we add the whole numbers. The whole numbers, again, from 4 7/20, 6 3/5, 7 1/4 is 4 plus 6 plus 7 equals 4 plus 6 is 10 plus 7 is 17 over 20. Now we combine these steps. 17 over 20. Wait, I'm sorry. There's no 20. See, even professors get mixed up sometimes. 17 plus 1 4/20 equals 18 4/20. I apologize for that. Next, what are we doing next? We are subtracting like fractions. Because this video is already over 30 minutes, I'm not going to go into the subtraction simply because it's exactly the same as the addition, only you subtract. So let's get rid of that. So multiplying proper fractions. 2 steps. Nope, I'm lying. There are not 2 steps. Nope, there are 2 steps. Sorry about that. Multiply the numerators and the denominators. And what we're given is 5 over 1 times 1 over 6 times 4 over 7. So our first step is to multiply the numerators and the denominators. And then is to reduce the answer to the lowest terms or use the cancellation method. Okay, so what do we mean by multiply the numerators and the denominators? Well, first, let's go with the numerators. 5 times 1 times 4 over, now let's do the denominators, 1 times 6 times 7. which is equal to 5 times 1 is 5 times 4 is 20. 1 times 6 is 6. 6 times 7 is 42. So our answer is 20 over 42, but we know that each of these numbers is divisible by 2. So 20 over 42 is the same as 10 over 21. So the other way that we can get to this, and it's not really 2 steps, it's just a different way to do it. So 5 over 1 times 1 over 6 times 4 over 7. We can look at this and know that for this numerator, oops, sorry about that, this numerator 4 is divisible by the same number as this denominator. So if we want, we can cancel these out. So 4, sorry about that, 4 we want to strike through. And 6 we want to strike through. And for whatever reason, it's not striking through. Oh, did that time. Oh yeah, it did. It's just put it where the line was. So when we strike through, we are then saying that 5 over 1 times 1 over 3, because 6 and 4 are each divisible by 2. So 1/6 becomes 1/3 times, and it only works if we also reduce 4/7 to 2/7 because we're dividing that. Honestly, the book teaches this method. I don't recommend it. It's just too easy to get turned around. But we come up with the same answer. 5 times 1 times 2 over 1 times 3 times 7 equals, okay, 5 times 1 is 5 times 2 is 10. 1 times 3 is 3 times 7 is 21. So these are two different ways to get to the same place. The A method is much easier and error proof, I guess I should say, than the B method is. Now, how do we multiply mixed numbers? Well, first, we convert the mixed numbers to improper fractions. Then we're going to multiply the numerators and denominators like we did above. Then we're going to reduce it to the lowest terms. So the problem we were given was 2 1/3 times 1 1/2 times, nope, that's all we were given. So first we convert to improper fractions. And to do that, remember 2 1/3 becomes 3 times 2 plus 1 over 3. And 1 1/2 becomes 2 times 1 plus 1 over 2, which, once we multiply everything out, well, we're just converting right now. We're 6, 3 times 2 is 6, plus 1 is 7 over 3. 2 times 1 is 2, plus 1 is 3 over 2. So 7 times 3 over 2 equals 7 times 3 over 3 times 2, which is equal to 21 over 6. We know that 21 and 6 are each divisible by 3. And again, we know this by inspection. In other words, just looking is just something that we know. So 3 divided by 21, or 21 divided, 3 divided into 21 is 7. And 3 divided into 6 is 2. And now we convert this to a mixed number. 2 will go into 7 twice. It's 2 times 3. 2 will go into 7 3 times. 2 times 3 is 6. So we've got 3, remainder 1. 3 1/2 is ultimately our answer. Next, dividing proper fractions. Three steps. Invert the divisor. The inverted fraction is reciprocal. So what the heck does that mean? We'll come back to it. The second step is you multiply the fractions. And then finally, you reduce to the lowest terms. Okay, so invert the divisor. What in the world do I mean by that? And here is our problem that we're given. I'm using this like the dot line dot symbol, but I don't have that. So 1 over 8 divided by 2 over 3 is our problem. So invert the divisor. What does that mean? That means that 1 over 8, then we invert the second fraction, which is the divisor. So 2 over 3 becomes 3 over 2. So again, the divisor, 1/8 divided by, I'm sorry, 2/3 divided by 1/8. The divisor is the number that is getting broken up by the number that we're dividing into it. So from here, it's pretty easy. Remember, we multiply the fractions. So we changed it from a division problem to a multiplication problem. So 1 times 3 over 8 times 2 equals 3 over 16, because once again, 1 times 3 is 3, 8 times 2 is 16, and that is the lowest term because we cannot evenly divide 3 into 16. Oh, sorry, multiply the fractions. Reduce to lowest terms. Sorry, I got ahead of us there. Now, dividing mixed numbers is exactly the same. You convert them to improper fractions. And then you invert the divisor and multiply. Excuse me. And the numbers that we're given are 8 and 3, 8 and 3, 8 space 3/4 divided by 2 5/6, and that is our well, I guess I don't need to because that's already done. I hope that makes more sense. It's 2 and 5/6 is the same as 2 plus 5/6. But when you have to list division signs as with the same as fraction signs, it becomes a little bit confusing. So first, again, we convert to proper fractions, or improper. So we remember how to do this. We say that 4 times 8 plus 3 over 4 equals 4 times 8 is 32, plus 3 is 35 over 4. And then we look at 2 and 5/8. We do this, or 5/6. We do the same thing. 6 times 5. Nope, I'm lying. 6 times 2 plus 5. Over 6. and that equals 6 times 2 is 12, plus 5 is 17 sixths. So then our problem becomes 35 over 4 divided by 17 over 6. So now we invert the divisor and we multiply. So 34 over 4 times 6 over 17. So then we multiply as we normally would. 34 times 6 over 4 times 17. Which gives us, oh, I don't have a calculator. And I need one for this, and it's okay for you to use one too. So I'm just going to use the calculator here. And it is 34 times 6. 34 times 6 equals 204. 204 over, and then 4 times 17, which is 68. And then we reduce it to the lowest terms. At least I think we do. I think we should. We shouldn't leave it at 204 over 68. It doesn't tell us to do anything else, but so I would accept either one. But how many times will 68 go into 204? 204 divided by 68 equals 3. Exactly 3. I'm really surprised there's no remainder. So that is the ultimate answer, is 3. Okay. Well, I know this has been almost an hour, and I don't expect that you will have watched it all in one sitting, but watch the parts that you need as many times as you need to. Call me with questions. I'm always here to help.